this final module, we will look at some of the key points around the design and construction process and the participating building professionals' roles and responsibilities for delivery of a successful mid-rise timber building. In this presentation, a brief summary will be made of the key controls that define the DTS solution for mid-rise timber buildings and the logic in terms of the staged fire design principles for protection. A discussion is then provided of the key roles and responsibilities of the overall project team, looking at each segment of the project process and highlighting the key points for consideration, from the initial design and documentation through construction to the final building handover and ongoing oversight. References will also be provided to the other educational resource modules, providing more detailed information on certain topics. In summary, in regards to the new deemed to satisfy provisions, if the building or building part is class 2, 3 or 5, the building has an effective height of not more than 25 metres and utilises automatic sprinkler systems, fire-protected timber, non-combustible insulation and cavity barriers where applicable, then it meets the deemed to satisfy solution for mid-rise timber buildings under the 2016 National Construction Code. If any items fall outside of these controls, then these will have to be addressed through a performance or alternative solution approach under the NCC. Detailed information is provided in modules 3, 4, 5 and 8 on the specific 2016 NCC requirements for fire-protected mid-rise timber buildings. In terms of the general fire design principles with mid-rise timber buildings and fire-protected timber systems, there are a number of critical but logical layers. The first level of fire protection comes through the use of automatic sprinkler systems, whose function is to suppress a fire before the timber structure is threatened. It is widely known and accepted that sprinkler systems greatly reduce the fire risk to building occupants, their property, and to firefighters if they need to attend a fire event. Secondly, the use of fire-grade plasterboard to effectively encapsulate and fire protect the timber elements. This means that in the very low probability event that the sprinklers might fail to activate, that the structural timber members are prevented or delayed from ignition during the growth period of a fire and prior to the fire brigade intervention. Thirdly, the use of cavity barriers to prevent the uncontrolled spread of fire or smoke through cavities in the low probability event of either a failure of the protective covering or of a fire starting within the cavity. And fourthly, the use of non-combustible insulation to minimise fire spread in cavities, again in the unlikely event that the fire-grade plasterboard is breached. Detailed information on each of these elements is provided in separate modules within this educational resource. For automatic fire sprinklers, refer to Module 6. For fire-protected timber, Module 7. For the use and placement of cavity barriers, Module 9. And for the use of non-combustible insulation, Module 10. A successful mid-rise timber building requires all building professionals delivering their roles and responsibilities correctly throughout the full design and construction process, starting with design and specification, then assessment to ensure that this design is in accordance with the NCC prior to construction commencing. Once construction is underway, ensuring this is done in a quality manner by all staff and contractors to the required design and specification and clear controls in place to inspect this construction work to ensure all key elements have been done correctly. And finally, building commissioning and handover. The following provides some guidance on roles and responsibilities, but the reality is for each project and each key phase, a specific responsible person has to be clearly and unambiguously identified to ensure success. In terms of the overall design and documentation, this will generally involve a wide range of design team members and contractors with specialist skills, and generally the senior project architect is the person with overall responsibility. In terms of assessment and certification of the design and documentation, the project building surveyor is generally ultimately responsible for signing off on compliance. During the construction phase, primary responsibility lies with the builder. This is arguably the most critical phase, as the building elements must be constructed as per the required design to meet the expected fire and acoustic performance requirements. Inspection of the construction works will fall to the responsible building surveyor, or perhaps the engineer, depending on the element being inspected. Finally, with commissioning, which may happen progressively and then a final commission, this is the responsibility of the builder and the senior project team representative to ensure that the project is completed as per the design and functioning appropriately. In the following sections, we will briefly summarise some of the key points for consideration for each of the stages shown here. Let's start off with some key points for the design team. A successful mid-rise timber building starts with the project team, the architect, engineer, quantity surveyor, building surveyor, and the builder, if known. Key issues for the design team include ensuring all fire protection elements required are clearly documented, including sprinklers, fire-rated linings and claddings, cavity barriers, non-combustible insulation, fire collars, etc. It is also a requirement under the DTS provisions that appropriate evidence of suitability exists and is provided for all products. It is also very important that everyone is quite clear about the different design and project team member responsibilities and roles. There are also some simple design methodologies or approaches that are recommended for use in mid-rise timber buildings that reduce some of the risks of inadvertent breaching of the fire-protected systems, either during construction or the ongoing life of the building. The first is the principle of designing so that service penetrations through fire barriers can be eliminated or minimised to ensure the integrity of the fire-protected timber elements are maintained. Design approaches to incorporating surfaces can include the use of false ceilings, the use of false walls when needed, or better still for electrical wiring and power points, the use of skirting ducts. Also the use of false walls to allow the installation of baths, and the running of plumbing within the SOU's floor void above the fire and sound rated ceiling. Service cores, runs and risers are also really important design concepts. These can be horizontal service runs above false ceilings, but fitted below the fire-protected timber ceiling system without penetrating the fire-rated linings. Or similarly, services can be consolidated and run in vertical service risers. Gathering services and running them together, particularly if the design allows them to be placed in non-fire rated shafts or runs, will make inspection and ongoing maintenance far simpler and straightforward. More information is provided on the efficient running of services in Module 16. From a design perspective, it is also really important in achieving the most time and cost-effective outcome that the design team engages with all key contractors in the preliminary design phase of the project. If the builder is known, they should be brought in early. With prefabricated timber structural systems, particularly cross-laminated timber, it is much more efficient if the prefabricated system supplier is involved at the earliest design phase to allow advice to be provided on the most effective configurations for system manufacture, supply and installation. To reduce construction time on site and therefore overall construction costs, opportunity should also be investigated into increasing the amount of prefabrication and off-site manufacture. In regards to services, early involvement in design layout also allows consideration of service grouping and placement. And if a timber lift shaft is to be utilised, then look to bring the lift supplier into the discussion early, as the accuracy of timber shafts is much higher than concrete, and as such, installation is likely to be more cost-effective. The most important point is to ensure that all members of the project team know and understand the requirements for a fire-protected mid-rise timber building. Let's now examine some key points around the assessment and certification of the design and specification. The following are suggested as some key points for assessment and certification. Firstly, it is the responsibility of the project building surveyor to ensure that the design and documentation is complete and in accordance with the NCC and the relevant local, state and territory building regulations that occur. An important step is to ensure that the appropriate evidence of suitability exists for all relevant products in the building. A good approach here is to utilise a spreadsheet of the different products that allows clear records to be kept of the compliant products used. This spreadsheet can then be used later on site to check the correctly specified products have been installed. If a non-DTS solution is to be used, then the building surveyor should ensure that the appropriate performance solution documentation, such as a fire engineer's report, is provided and maintained. Now, moving to the actual construction phase. As mentioned previously, this period is arguably the most critical phase, as the building elements must be constructed and installed as per the required design, if the fire and acoustic performance requirements of the system are to be met. It is particularly important that all on-site building staff are suitably trained, knowledgeable and competent in relation to mid-rise timber building requirements, and that all site contractors have explained to them and they demonstrate a clear understanding of the key issues with fire-protected timber construction. Also critically important is that all system elements must be installed as per the manufacturer's recommendations, particularly processes such as fire-rated lining installation sequence and sealing of joints. Proper process and quality practices must be a major aim. There are some activities that just have to be done correctly. It is also very important that on-site workers are diligent and report any concerns or observations of non-compliance to the project site supervisor. If a mistake is made, it is best and most easily fixed at the time. Focusing specifically on the fire-protected timber elements, the next slides briefly summarise some must-dos and highlight some of the important areas to be aware of. Firstly, all on-site staff and contractors need to understand that fire-protected timber systems are not the same as traditional timber residential construction. They may look somewhat similar, but they are in fact a system that relies on all of the elements being installed correctly to achieve the required system performance. Also, fire-protected linings must not be breached unless they have been designed and detailed to do so. Therefore, commonly accepted residential practices, such as simply cutting a hole in the linings to move a service point by example, are not allowed. Cavity barriers are also a key system component, and these must be installed as per the manufacturer's recommendations. It is the responsibility of cavity barrier installers to ensure that these products are installed correctly, and the responsible installer on each job needs to be clearly identified. It is also the responsibility of the builder, as the overall supervisor of the works, to ensure that these cavity barriers are installed at all locations required. As cavity barriers are such key elements that are quickly covered from view during construction, it is highly recommended that on-site building supervisors take and log photographic evidence of each installation. With everyone carrying a smartphone camera today, this should be quite an easy process. Cavity barriers to prevent smoke and fire travelling up the building if the fire-rated lining was to be breached or a fire started within the wall cavity are utilised at a range of key locations throughout the building, at floor junctions, external walls, around windows and doors, and in roof spaces, as seen here. Detailed information on the installation of cavity barriers is provided in Module 9. Compliant fire collars must also be installed where required, as per manufacturer's recommendations. It is the responsibility of the fire collar installers to ensure that these products are installed correctly, and the responsible installer on each job needs to be clearly identified. Again, it is highly recommended that on-site building supervisors take and log photographic evidence, particularly where installations are to be covered with linings or cabinetry. More detailed information on the protection of pipes through fire-protected walls is provided in Module 16. Care must also be taken with on-site activities or services connections where hot work such as welding and soldering might be used. Further information on this is provided in Module 16. Also, on-site fire protection as per NCC requirements must be provided. This is critical in reducing the risk of fires during the construction period. Detailed information is provided on this in Module 19. Finally, products and materials used on-site as part of the fire-protected timber systems must be as per the design and specification. It cannot be more strongly noted that no unauthorised on-site product substitution should be undertaken. If there are any proposed changes to the original design and specification, then this must be investigated and authorised by the project design leader, with any additional certification requirements also undertaken. Construction inspection is also a key project step. Requirements and responsibilities of this phase tend to differ between states, but ultimately one or more professional groups, such as the project building surveyor or engineer, are responsible to sign off that the building has been constructed as per the design. The following are suggested as key points during the construction inspection phase. It must be confirmed that all relevant fire-grade products, such as fire-rated linings, cavity barriers, non-combustible insulation, fire collars, and etc., have been installed correctly, and no product substitution has taken place without authorisation. All cavity barrier installation points need to be checked, and the barriers confirmed as installed. All fire protective linings should be inspected to confirm that there have been no unauthorised breaches and that proper encapsulation has been achieved. Building commissioning is also a key phase, though this may happen progressively for some processes before a final commissioning. The following are some suggested key points for the building commissioning process. Clearly identify at the start of the project process what the roles and responsibilities of the commissioning team will be and who will be involved. During the planning phase, identify key points where the fire protection systems might be commissioned and activated. Provide staged, regular and ongoing commissioning of fire protection systems wherever possible during construction. This staged commissioning assists in reducing the possible risk of a fire during construction. Assemble for the building owner or body corporate representative a detailed handover building manual that documents the key information on the building's usage and ongoing maintenance. Finally, let's look at some key points for the building when completed and for its ongoing use and maintenance. Once a mid-rise timber building has been completed with all its system elements adequately designed and in place, It has a very high level of fire and acoustic performance. Care then needs to be taken after handover with any future maintenance or renovation activity that protection and performance is maintained. To try and assist with ongoing integrity of the fire and acoustic performance, it is suggested that the building supervisor and/or body corporate be provided with a written and illustrative manual documenting all the key relevant fire considerations, and that these documents are clearly explained to them. It is also suggested that simple illustrative and coloured floor plans be provided clearly indicating the key fire protecting elements such as walls, ceilings and structural members. Copies of these floor plans could be placed in each SOU meter box and in the main building service rooms and areas. It also needs to be clearly understood by the building owner, manager and occupants that the fire-rated wall and ceiling linings and other fire protecting elements must not be removed, altered or breached without advice from an authorised fire engineer, and that false ceilings or wall plenums must not be totally removed without advice from an authorised building inspector. The building owner or body corporate representative must be consulted before any works likely to affect the building fire or sound performance are undertaken. So in summary, to comply with the new NCC deemed to satisfy provisions, the project team needs to ensure that there is a clear understanding and implementation of all the required fire protection system requirements. A successful mid-rise timber building project will require awareness, appreciation, action and application at all phases. Design and documentation, assessment and certification, building construction, construction inspection, building commissioning, and finally in the future with ongoing maintenance and oversight. This is the final module in this series of 20 modules that make up this mid-rise timber building educational and training resource, which has been prepared based around the information provided in the Wood Solutions Technical Design Guide number 37, Mid-Rise Timber Buildings. To access these resources and a wide range of other wood-based information, go to woodsolutions.com.au, the website for wood.